let's talk about the application problem, okay? Where basically like old math courses designed like this way, okay? We will teach you basic stuff, and then like, we're gonna give you one crazy problem which is combined all the knowledge, okay? And then we give you some application problem, which is real life problem, okay? Well, good news is this is not something new. You know all these things from your high school physics course already, okay? So basically, let's say given function s is given as like position function, then s prime is the velocity function v, okay? And what is b prime? Which is s double prime is acceleration. That's it, okay? So we know how we can find first derivative, and we know how we can find second derivative, okay? It's easy process, okay? But the meaning of like all those things are velocity and acceleration from position function, okay? That's it. Now let me give you the example, okay? A ball is thrown vertically, okay? Hit the ground, okay? So that is the problem, okay? So you just throw the ball like to upward, vertically upward, okay? And going up, like maybe like, there is the initial velocity, right? Phew, and slow down and hit the like, the highest place and coming back to the ground and hit the ground, okay? So like this ht is the height of your ball, right? But that really makes sense, right? Think about the graph of that one. Okay? It's quadratic, which means like going up and down. Does it make sense? Okay. So like we can say h of t is the position function. Okay. Then we're going to talk about the maximum height of the ball. Think about it. Just through the ball, and some point it will be stopped. That point is the highest, maximum height of the ball, right? And what happened at that moment? As you can see, like it is the velocity equal to 0 point. Okay, so like for this problem, we can figure that out. Okay, for the maximum height means your velocity is equal to 0, or in another word, your velocity is h prime t is equal to 0. That's it. We figured everything out now. Okay, your h of t is given, which is height, or we can say it's position function. Okay, then what we want to find is h prime t is equal to 0 point. Okay, so here we go. Take the derivative. H prime t is equal to 80 minus 32t. Okay, and to find the maximum height, and we're going to set that equal to 0. Is that clear? Okay, just subtract 80 on both sides and divide by negative 32 on both sides, okay? Then your t is negative 80 over negative 32, which is 80 over 32. Then if you just divide by 16 top and bottom, it is 5 over 2, okay? Or 2.5 seconds, okay? So this means after 2.5 seconds, and your ball will be at the maximum height, okay? Does it make sense? So like what is maximum height? Then we just simply plug in your 2.5 into your height function. Not h prime, but you have to plug in back h of t, because h of t will give you the height of the ball, okay? So the maximum height is h of 5 over 2, right? So it is 80 times 5 over 2 minus 16 5 over 2 squared, okay? So that is 40 and 200, right? And it is negative 16 over 25 over 4, which is 4 times 25. Am I doing right? 4, 2,500, right? So that is equal to 100 feet. That's it.